Hi, my name is Ryan Booz. I'm a solutions engineer here at pganalyze, and today I'd like to continue our conversation about pgstat statements and specifically where those query texts are actually hiding when you query pgstat statements. So we've talked in the first two episodes about a couple of things. Number one, the actual metrics that are being tracked by pgstat statements is an in-memory hash table. That's why, as we talked about in the first episode, we need to configure pgstat statements as part of the shared preload libraries configuration in Postgres. And in the last episode, we saw that pgstat statements has a maximum number of queries it will track based on the max setting. And metrics are stored based on the normalized version of the query structure, that query ID, and then per role per database, not the query text that we see. The text, it turns out, is not stored in the in-memory hash table. It is stored in a separate file on disk in the data directory. Now, normally it tends to be in the pgdata global directory. Some Docker installations, I've found it inside of a pg_stat_temp directory, but it will be in there somewhere. And this is the actual file that's tracking the texts of those statements. Now, this file is append-only for new pgstat statement query entries. So every time I run a brand new normalized query, that text that I am executing is what gets written into this file. And this file is allowed to grow approximately 2x of the mean size of queries tracked in the in-memory hash table. And so as it's writing to this file, part of what's happening in memory is it's always keeping track of what that mean length is of the currently tracked queries. So when I select star from pgstat statements or use the function, if I say true from the function, I will get the query texts. If I say false in the function, I will not get the query texts. As a quick example, if I say false, you'll notice query is not anywhere in here. As soon as I say true, I get the query text here. Now, how this works is in pgstat statements, that in-memory hash table, for every entry, there's essentially a pointer to where in that text file the query text can be found, an offset and a length. So it will say, hey, go to this location in that file and read this many bytes, and that is the query text. And so that file is essentially hidden from us, something we'll never see, but this is tracked with every entry inside of pgstat statements. Now, the interesting thing here, and again, what I'm trying to demonstrate, there's a lot more happening under the covers than most of us have been led to really understand in how we're trying to use pgstat statements. Pgstat statements has no memory of previously tracked query IDs. So going back yet again to that max value, if I had 5,000 max statements and I've had that many unique entries inside of pgstat statements, and some are evicted to make room for new queries. If I later run a query that used to be in pgstat statements, it doesn't know that. It's an in-memory hash table. So the new time it comes in, it says, oh, this is a new query. And it will write a new version of that text to the file. It doesn't know it existed previously. Again, it's just tracking an offset inside of a file. So you can actually have multiple versions of the same query text inside of the query text file. We have to recognize that the total number of query texts tracked in this file is not pgstat statements.max. It is based on size. So it's 2x, the total number of queries I can track, times the mean length of all of those queries. And then when it reaches that size limit, it doesn't clean out the file. It simply rewrites the file based on what is now currently active inside of pgstat statements. And then it does a quick swap. It drops the old one, renames the new temp file back to the new one. And there's a quick moment of locking there. So this is a management issue we have to begin to be aware of. If I track, going back to the last discussion we had, 10,000 or 20,000 or 50,000 statements, this file can grow very large. As a really quick example, I happened to query my local copy of a Postgres server I had, and it was set to 5,000 queries. I had about 5,000 queries in there. The mean length of my query text was about 900 bytes times 5,000, and then twice that meant that my file could grow to about 8.8 or 9 meg before pgstat statements would rewrite it. Just recognize this file size limit really can grow pretty quickly. If I have a lot of pgstat statement, if my max is set really big, or I have a lot of very large texts, it's the mean length. It doesn't matter if my texts are, kilobytes of text every time, and I can track 5,000 of those, that file can get really big. It could get to hundreds of megabytes that's being stored and rewritten on disk often. It's something we have to understand to manage. And I want to point out that one thing that really likes to write large query texts is ORMs. ORMs really don't care about the structure of the text they're writing. They just care that they abstract what you are asking it to query into SQL text that Postgres can then parse. And those query texts can get very large. And that could mean that this file is getting large. And it means then when it has to be managed, there could potentially be some locking issues. And so that's what we're going to look at next. We're actually going to go to the source. We're going to look at how each of these things happen inside of what pgstat statements is doing. Where's that 2x file size? How does limit work? What gets evicted? What doesn't get evicted? Are the metrics for the query that you need to look at right now actually available in pgstat statements? And if not, is there a way that we could configure this to be more sure that we'll have access to that data? And that's what we'll then talk about in the final episodes. So I hope understanding where those query texts are is helpful, gives you a new perspective on exactly what you're seeing when you query this data. And we'll get into the details in episode 4. We'll see you then.